All right, thanks for joining me, and let's have some fun. We are going to do some multiplying of integers today. Multiplying of integers is just like multiplying the positive numbers you learned in elementary school. It's not that difficult, so we'll just walk through this. A few things we want you to know to make your life easier. Remembering that the multiplication is commutative is going to help you quite a bit. So I'll give you a minute, pause, write this down, and then we'll come back and talk about it. The commutative property basically says it does not matter the order in which I'm multiplying two numbers together. If I have 2 times 3 and if I have 3 times 2, they're going to result in the same product. If I have 2 3 times or 3 2 times, in both places I'm going to get a 6. All right, so it does not matter in which order I multiply these two together. It's the same for addition of regular numbers and even of integers. It's commutative. It doesn't matter which way I add them together. Again, for some of those things, if I'm moving through it too fast, just go back and hit the pause button and copy it down. So what does this really mean when I'm talking about positive integers? Well, this just means that I want 3 times 2. I can have the groups of 2 3 times. Here's a group of 2, here's a group of 2, here's a group of 2. 3 groups of 2. How much is that? 1, 2, 3, 4, 5, 6. So my total answer would be 6. 3 times 2 is 6. Now you might be saying, holy cow, we already learned this in elementary school. Why do we have to learn it again? Well, we're just discussing it because they are integers. Remember, integers are our counting numbers and they're opposites. So 3 is a counting number, 2 is a counting number, therefore they're integers, and we're going to talk about how to multiply them. Now what happens when I'm multiplying negative numbers? I need 3 times negative 2. I need negative 2 to happen 3 times. All that changed was which chip I was using, which value I was using. This time I have 2 negatives that occur 3 times. So in this case, let's count. I have 1, 2, 3, 4, 5, 6. In this case, my answer is a negative 6 because I took that negative 2 to occur 3 times. Negative 2 plus negative 2 plus negative 2 is negative 6. So what happens if the first integer happens to be negative? Well, that's the beauty of the commutative property we just talked about. Multiplication is commutative. So I can just take this, turn it around, and say that I want 2 times negative 5. If I look at this as 2 times negative 5, well, that means that I want 2 groups of negative 5. So here's my group, 1, 2, 3, 4, 5. Here's my other group, 1, 2, 3, 4, 5. And so my final answer shows me that I have a total of 10 negatives. 2 times negative 5 is negative 10. I can just use the commutative property and turn that around. All right, so now we have some issues. What if both of them are negative? What if both of them are negative? Negative 3 times negative 4. So let's go back and just quickly review on what we had here. We had 2 times 3, 2 times negative 3, negative 3 times 2. We didn't use those numbers, but these were the patterns. They were both positive. One was negative. The first one was negative. And now we have a case where they're both negative. What I want to show for you here is a different pattern of what's going on. So let's say that I had 3 times negative 4, 3 times negative 4, and then I want to have 2 times negative 4, 1 times negative 4, 0 times negative 4, negative 1 times negative 4, negative 2 times negative 4, and I'll scroll this down a little bit so we can see negative 3 times negative 4. So let's ask ourselves, what is going on here? Let's work with what we know. We already talked about this. This means a group of negative 4 3 times. Negative 4 plus negative 4 plus negative 4. 4 negatives plus 4 negatives is 8 negatives, plus 4 more negatives is 12 negatives. What if I had a group of negative 4 2 times? It would be 8 negatives. What if I had a group of negative 4 1 time? It would be 1 negative, or 4 happening one time. What happened if I had 4 negatives happening no times? It would be 0. So now I'm looking at each one of these and I'm saying, wow, they look like they are decreasing. This one decreases by 4, this one decreases by 4, this one decreases by 4. I bet this is going to, oh, I apologize, not decreasing. My goodness, Miss Bednar, you need to know your number line. These are increasing, increasing by 4, increasing by 4, increasing by 4. So what's going to happen here? It's going to increase by 4. And what's going to happen here? It's going to increase by 4. And what's going to happen here? It's going to increase by 4. So wait a second. Now we find out that a negative 3 times a negative 4 is a positive 12. Following the pattern, we can see that a negative 3 times a negative 4 is a positive 12. We can look at a grid such as this to help us with multiplying our integers as well. This is something that you're going to do for homework in class, so I'm not going to give away all the answers here right now, but it was similar to our multiplication chart. Our multiplication chart in class. Give me one moment here.
Okay, Math League, is it the same as last year? Tuesdays and then the occasional Monday, like every third week?
Yes, and Miss Nelson is going to have the
Nelson?
science. Yes, she's getting them printed, so we're just waiting for them to come back and print.
Okay.
I think it's the
Yep.
second week in October is our first practice.
Okay.
I'm pretty sure. I'm off. That's awesome.
All right, so let's run through a bunch of examples, one after another. If you think you've got it down, if you think you know the pattern, hit pause, come back and see. If you're not sure, walk through them with me. So this is just another way to show multiplication. We show it as 4 times 5 by just using parentheses next to each other. 4 times 5 is the same as 20. Oh, my pen is deciding not to work here. Let's see if we can get this to fix itself. 4 times 5 is 20. What happens if I now have 4 times negative 2? Well, let's go back and just remember what it means to be a multiplication problem. The joys of technology, it won't let me write any higher than that, so I apologize, I'll have to write underneath it. 4 times negative 2 means a group of negative 2 happening 4 times. Negative 2 plus negative 2 plus negative 2 plus negative 2. A group of negative 2 happening 4 times is 2, 4, 6, 8, negative 8. What about if I had this? Well, that's where our pattern came in. And we noticed in our pattern, if I can go back here and show you, in our pattern, when we had 2 negatives, we ended up with a positive answer. So what do you think is going to happen in this pattern? The same thing. The 2 negatives multiply together to give us a positive answer of 28. What happens with 9 times 12? Oh, wait a second. How do I know that's a times? It's another way to write times. Negative 9 times 12. I can use the commutative property to switch this around and write it like this. Or I can read it differently. Negative 9 12 times. I can read it that way. Negative 9 12 times. So negative 9 12 times would be negative 9 plus negative 9 plus negative 9. And that's going to be a lot to write out. I'm going to run out of room. Or I can just multiply it. 9 times 12 is 108. And then know that it's going to be negative because all those would be negative adding together. Let's talk about this one. It still won't let me write there. Let's try raising it up higher. There we go. We can do that here. So we have 5 times negative 2. 5 groups of negative 2. 5 groups of negative 2 would be negative 2, negative 2, negative 2, negative 2, negative 2. 2, 4, 6, 8, 10. 10 negatives. And then I can do the next one. Negative 3. Negative 3 and negative 10. I've noticed the pattern that when I have 2 negatives, it's a positive, so I'm just going to multiply them and get a 30. Here we go. In this case, I'm going to use the commutative property because I would like to take this 7 and put it here and put the negative 1 at the end. 7 times 7 is 49. Positive 49 times negative 1 is going to be negative 49. When I have one of each, the sign is negative. All right, here we go. Have to scroll it down again so my pen will work. Negative 4 times negative 2. We've noticed in our pattern that when I have 2 negatives, they become positive, so that's going to be an 8. So now I have 8 times negative 2. 8 groups of negative 2 is going to give me 16 negatives. How about 2 times 3 times negative 2? 2 times 3 is 6. 6 times negative 2 is going to be 6 groups of negative 2, which is a total of negative 12. 6 groups of negative 2 is a total of negative 12. This is a pretty easy section. Once we got past subtracting integers, multiplying and dividing, it's fairly easy. So we're going to just go through this very, very quickly. The Minnesota State golf team has 4 golfers that each have negative 6 on their rounds for the day. What is their team score? So a few things. They're under the score that they need to have, and there were 4 golfers who did that. So if I was to represent this as a multiplication problem, it would be 4 golfers times a score of negative 6. Negative 6 happening 4 times. If negative 6 was happening 4 times and I totaled all of their scores up, I'm going to look and say, okay, 6 times 4 is 24, but it's under, so it's 24 negative. All right, Alicia owes $9 to 3 of her friends. So if I owe $9, it's negative $9 I have. And I have 3 friends that I have to give it to. Well, we're kind of finding out a pattern here that really what it is this number, negative 9, 3 times. So it's going to be a total of a negative 9, 10, 11, 12, a total of negative 12. 12, oh my goodness. It just thundered outside, so I'm focusing on that. Negative 27, I apologize. All right, Lily bought 4 pairs of blue jeans at $32 each. How much money does she have to pay the clerk? Notice what kind of integers these both are. They're positive. She bought 4 pair. She bought them for $32, so she has to pay back a total of $128. When we set these up, this is a great question. Normally, I don't spend a whole lot of time on these. However, when we're multiplying, we have to be careful we place the parentheses in the correct spot. So we have A. A is negative 4. So I'm going to place a negative 4 here, and I'm going to put parentheses around it just to make sure everyone knows that I'm talking about a negative. B is 5. I could just put the 5 here, but I'm still going to put parentheses around it just to make everything look nice. And again, especially around the 6, to show the fact that I'm not subtracting it, but I'm multiplying it. So now I have to multiply these. I could choose the commutative property. I could bounce some of these around. Let's say I wanted the 2 negatives to be multiplied together to give me a positive. For me, I'm going to multiply the 4 and the 5, the negative 4 and the 5. So I end up with a 20, negative 20. Because I know I have 4 5 times to give me negative 20. And then I'm going to multiply that by a negative 6. Now I know that when I had 2 negatives, the pattern that we had followed before, the 2 negatives are going to result in a positive. And I have 6 times 2, which is 12, and I put the 0 on there for a total of 120. All right, a squared. We haven't talked a whole lot about what it means to be squared yet in exponents. We're going to talk about more about exponents soon. But what does this mean? This means the same thing as the letter A times the letter A. So I know that A is a variable that stands for negative 4. So I have negative 4 times negative 4. Again, I can put these in parentheses to ensure that everyone knows that I'm attempting to make them a negative and not subtracting each other. I also know from my pattern that 2 negatives turn into a positive, and 4 times 4 is 16. Last but not least, I have A times C. A is a negative 4, C is a negative 6, and when I multiply 2 negatives together, I end up with a positive, and 4 times 6 is 24. This is a very quick summary for you to use. However, you have to make sure that you are focused on what you are doing mathematically. Are you multiplying? Are you dividing? Are you adding? Are you subtracting? Use your common sense. Put it into some sort of dollar problem using money to help you better understand. If you use tricks of the trade, so you know what your answer is. Sometimes what happens is we get confused with the tricks of the trade and we apply them to the wrong problems when we shouldn't. All right. Thank you for your time, and I hope that you have a great time doing your homework.